Hello, Algebra 2 students. Welcome. Today we're going to be covering the Unit 1 activity. And so if you're in the right place, great. If not, well, that's what we're covering right here. So let me share my screen with you guys and we'll go ahead and get started. The unit activity should look like this. There's an introduction, blah, blah, blah. Talks about Melissa's garden design. Okay, she's got a garden, whatever. Okay, let's move on to the questions here. Melissa is planning a rectangular vegetable garden with a square patch for tomatoes. She wants the length of the garden to exceed 3 times the length of the tomato patch by 2 feet. Okay. She also wants the garden's width to exceed the width of the tomato patch by 5 feet. Okay. So for this, let me just try to draw a picture here. So the tomato patch is going to be a square. So it's going to be a square for the tomato patch. And the garden itself is a rectangle. So it'll be something like this maybe. Okay. Well, I want that to go behind. Maybe I can do that here. Order, send back. Cool. Okay. So this is for the tomatoes here. I'll put a T here for tomatoes. And this whole thing is the whole garden. Okay. I know she wanted a square for the tomato patch. Now, for the length and the width, we're going to go and put X. Notice it's X and X because it's a square. So the length and the width will be the same. Now, it gives us some information about the length and width here. It says she wants the length of the garden to exceed 3 times the length of the tomato patch by 2 feet. So 3 times the length of the tomato patch. And we want to exceed that by 2 feet. In other words, we want 2 feet more. So the length, if the length of the tomato patch is X, the length of the whole garden will be 3 times that plus 2 more. Then it says about the width. She wants the garden's width to exceed the width of the tomato patch by 5 feet. So if this is X, this will exceed it by 5. So that's going to make it X plus 5. So I want you to go ahead and answer those there. So it'll be the length equals, and then write what we wrote, width equals. So here's what you'll put for the length and the width. So 3x plus 2 for the length, x plus 5 for the width. Now we want to calculate the perimeter. Now the perimeter, let's see, the perimeter of the whole garden. Okay. So if this length is 3x plus 2, then this length is also 3x plus 2. And if this width is x plus 5, as will this be. Now to find the perimeter, what you want to do is add up all of these outside edges. Okay, don't worry about the tomato patch, just the outside edges of the garden. So x plus 5 plus 3x plus 2 plus x plus 5 plus 3x plus 2, and that'll be the full outside edges, the full perimeter. Okay, so you're going to go ahead and add all those together, and don't forget to combine like terms. So I'll go ahead and let you do that. You can pause the video, add these terms, add these together, and combine like terms. Yep. Now, the area of the vegetable garden is 170 square feet. Which equation can be used to find the length of the tomato patch? So for this one, we want the area of the garden. The area of the garden. So to find the area, what you do is you do length times width. So we're going to go ahead and do that. So it's going to be 3x plus 2. And again, this is the area times x plus 5. So the length times the width. Hopefully you know how to do that already. Hopefully you know how to multiply two binomials together. But if not, that's okay. We'll go ahead and do it together. So 3x times x is 3x squared 3x times 5 is plus 15x. 2 times x is 2x, so plus 2x. And then 2 times 5 is 10. So this is the area of the garden in terms of x. Now, we can go ahead and combine the 15x and the 2x. So that is going to be 3x squared plus 17x, combining the 15x and 2x. That makes 17x plus 10. And it says that this area equals, what did it say? 170. 170. So if we want to find x, what we would need to do is we need this 170 would actually need to be 0 over here. So the way we do that is go ahead and subtract 170 on both sides of the equation. Canceling. Subtract 170 from the 10. Okay. So it'd be 3x squared plus 17x minus 160 when you combine these together. So again, that's 3x squared plus 17x minus 160 equals, and this over here would be 0. Okay. Let's go ahead and click the correct answer there. Melissa wants to make a table representing the area of her vegetable garden for a variety of different lengths of the tomato patch. She uses her area expression to create the table. Complete the table by typing the correct answer in each box. Use numerals instead of words. Do not round your decimal answers. Okay. So what we're actually going to do, we're going to fill in these two right here first. Okay, so we're going to do the ones where they give us the length of the tomato patch and we find the area of the garden. Okay, so the way we do that, let's go back to what we had right here. 3x squared plus 17x plus 10. I'm going to go ahead and write that on another slide here. So that was 3x squared. What was it? Plus 17x plus 10. Now, one of the things we need to answer is what would be the area of the vegetable garden if the length of the tomato patch is 6.5. In other words, x is 6.5. So what we're going to do here is we're going to replace x with 6.5. Let's go ahead and work out what that is. So it's 3. Replacing x with 6.5 instead of x squared, it's going to be 6.5 squared. Well, that's not very good. Let me try that again. Squared. Good. Plus 17x, so that's 17 times x, which x is 6.5 here. 17 times 6.5. And then plus 10. Okay, so we're going to want to work out what that is. Let me go ahead and grab my calculator here. Okay, so when we want to solve this, the first thing we're going to do is 6.5 squared. So 6.5 squared, and then times 3. Okay, times 3. So I've got 126.75 plus then 17 times 6.5. That's 110.5. Then plus 10. Okay. Then we're going to go ahead and add those together. So 126.75 plus 110.5 plus 10. And that gives us 247.25. So we'll go ahead and fill in the chart. 247.25 goes right here. There you go. I want you to try this one, where the length of the tomato patch in feet is 7. So you go ahead and do the same thing we just did, except instead of replacing the x with 6.5, like we did here, you'd replace the x with 7. So it'd be 3 times 7 squared plus 17 times 7 plus 10. Go ahead and figure out what that is, and whatever you get for that answer, go ahead and put it right here. Okay. Now let me teach you how to fill in these two blanks. These are actually the harder ones. Okay, so here they give you the total area already, but we need to find the length of the tomato patch. So let me go ahead and get rid of all of this. And in the first example, the area of the area of the whole garden was 338. 338. Okay, so now the first thing you want to do is you want to make it 0 on this side. So you want this to be 0. What we're going to do is go ahead and subtract 338. That'll cancel that. Subtracting 338 to the left side of the equation. Remember, whatever you do to one side, you do to the other. We'll combine it with this 10 here. So that'll be 3. I'm going to write it all the way over here to the left. 3x squared plus 17x minus 328 equals, and on the other side, this cancels, so that's 0. Okay, so now we're going to use something called the quadratic formula. I'll show you what it looks like. Here's the formula here. Negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Hopefully you remember this from Algebra 1. But if not, we'll go over it here. I'll show you this example. So basically, we need to look at this quadratic here, and we want to find the a, the b, and the c. See if you can figure out what a, b, and c are. Hopefully you got that a is 3. The a is whatever's next to the x squared, the coefficient for the x squared. The b is the coefficient for the x. So in this case, b is 17. And the c is the constant. In our case, that's negative 328. Now, what we do with these numbers is we plug them into this formula. So everywhere you see an a, right here and right here, you're going to replace that with a 3. The b's will be replaced with 17, and the c gets replaced with negative 328. So let's go ahead and work out this example. So it'll be negative b becomes negative 17. Just replacing the b with 17. Plus or minus. B squared is 17 squared. Minus 4ac is minus 4 times a, which in our case a is 3, times c, which in our case c is negative 328. And this is all in a square root. All over 2 times a, 2 times a is 3. Okay. Let's start working out what this is. So that's negative 17 plus or minus the square root. Now let's go ahead and figure out what this is. So it's 17 squared. Okay, that's 289. And then negative 4 times 3 times negative 328. That'll come out to a positive because you have that negative 4 times another negative 328. Negative times negative makes positive. So 4 times 3 times 328, 3,000. And again, it makes it positive because the negative times negative. So positive 3,936. All over 2 times a, so that's going to be 2 times 3, which is 6. Okay, So that's going to be negative 17 plus or minus the square root. Let's go ahead and add these two together. 4, 2, 2, 5, all over 6. Now, hopefully you know how to take a square root. On your calculator, there's usually a square root button. It's usually, you'll find x squared. The square root will either be like the next function by that. You might have to press the second key. Hopefully you get the second key. Mine, no, I don't need to do that, but on main calculators, you have to press the second key to get to the square root. But if you can't figure out how to use your calculator, you can always look up a calculator online. So do the square root of 4,225. So that's going to be 65. So this becomes, let's go, whoop, and slip there. Okay, so this becomes negative 17 plus or minus the square root of 4,225 was 65, or is 65, all over 6. Now this is going to give you a plus, a positive answer, and also a negative answer. But remember what we're finding. We're finding the length of the tomato patch, right? So can the length of a tomato patch be negative? Well, no, that doesn't make sense. So we're only going to be concerned with the positive version here. So we're only going to be concerned with the positive answer we get here. So negative 17 plus 65 divided by 6. Or 6, see? So that'll give us 8. So that means that if the total area was 338, then the length of the tomato patch would be 8. I'm going to go and put 8 right there. Now I want you to try the next one. Okay, try the next one. In this case, instead of a 338, it'll be 147.25. Go ahead and look at that example. Pause it if you need to. But it'll be the same equation. It'll be the same equation here, except instead of a 338, the number that would go here would be 147.25. Okay. All right. So you'd subtract that from both sides like we did before. Subtract the 147 on both sides of the equation. Find your A, B, and C once you have it equal 0. Plug it into the formula. So you have this example, and you've seen this before in Algebra 1. So go ahead and give that a try. Okay, part B. Melissa reserves another rectangular patch for her vegetable garden for growing bell peppers. Since the space that she can reserve for a rectangular bell pepper patch depends on how large she makes the tomato patch, she uses function P to represent the area of the bell pepper patch, where X is the length of the tomato patch. Okay, so this green parabola here is the potential areas for the bell pepper patch, but it depends on X, which if you recall, X is the length of the tomato patch. So the bigger she makes the tomato patch, the less space she'll have for the bell pepper patch. Okay. So what kind of function is this? What kind of graph is this? Well, it's a parabola, right? And what kind of function produces parabolas? Well, that's going to be a quadratic function. And it's quadratic, you can tell because it has x squared in it. And also it produces a parabola. When the length of the tomato patch is 8 feet, the area of the bell pepper patch is, so for that, we're going to go ahead and replace 8 into this function here. So what will that look like? So it'll be negative 0.5 x squared plus 6x. Now, in the case where the tomato patch's length is 8, what we're going to do is plug an 8 into this function. So that'll be negative 0.5 times 8 squared plus 6 times 8. Sorry, my writing's not the best here. So when you do this part, you do the 8 squared first. So do 8 squared first, then multiply by negative 0.5. So that'll give you negative 32 plus 6 times 8, which is 48. And then add those together. So that'll be 16. So if the area of the tomato patch is 8, then the area of the bell pepper patch will be 16. And you can see that from the graph, hopefully. When you look at 8 right here, you go up. Notice it hits this green graph at 16. So the graph also makes sense with that. The maximum possible area for the bell pepper patch is, so the maximum, where should I look for the maximum? What's the highest point? So what's the highest point for this? Well, it's when x equals 6, but the area of the bell pepper patch is the y-coordinate. So that's 18. When the length of the tomato patch is 6. So when the tomato patch's length is 6, the bell pepper's patch can be allowed to be 18. Okay. Match the real-world descriptions with the features that they represent within the context of Melissa's garden. Not all tiles will be used. All right, so the domain, we're still talking about this graph here. The domain are the x values. Now, the domain are the x values, so those will be all possible areas of the tomato patch. The y values is known as the range. What does the range represent? What does the range represent? Which of these makes the most sense what the range represents? Now let's look at the x-intercepts. So the x-intercepts are where the graph crosses the x-axis, here and here. Notice for those two spots, the area of the bell pepper patch would be 0. Right? There wouldn't be a bell pepper patch, essentially, at these two locations. So the x-intercepts, the area of the tomato patch when the length of the bell pepper patch is 0. Similarly, the y-intercept is the opposite. The length of the tomato patch. Oh, wait. No, this goes right here. Length of the tomato patch and the area of the bell pepper patch is 0. The other one's the opposite. The area of the bell pepper patch when the length of the tomato patch is 0. Okay, and I'll leave this one for you to figure out. What does the y values represent? What is the range? Okay, so now we want the domain and range for this. What are the domain and range for the function p within the context of Melissa's garden? So if we look at this graph, its normal domain would be from -infinity to infinity because it goes on forever in both directions. To the left, it continues going down and to the left, and it continues going down and to the right. So although it's not clear that 14 would have a point, it would like lower down. And so with 16 and 100 and a billion, right? And same with the negatives. So normally this graph would have a domain of all real numbers. In other words, from negative infinity to infinity. But in the context of this problem, you can't have a negative length of the tomato patch, right? And also you can't have a length tomato patch above 12 either. So the domain of this function in the context of the problem would be from 0 to 12. So the domain, I'm going to put these ones from 0 to 12. And these types of like square brackets means that 0 and 12 are included. What about the range? Well, the range are the y values. Notice the lowest y value. Well, it keeps on going down forever, right? So the lowest range value would be negative infinity. However, in the context of this problem, you can't have a negative area of the pepper patch. That doesn't make sense to have a negative area of a gardening patch. So the lowest it can be is 0, realistically. You could have 0 area for the patch, right? In other words, you just won't have bell peppers. And then the highest point would be the maximum of the range, in this case 18. So the range goes from 0 to 18. And again, we want to use these square brackets because these values are included. They are part of the domain and part of the range. 0 and 18 are part of the range, so they're included. Okay. You use these like regular parentheses. If this value is not included, like it goes up to that value but not including it, you would use these parentheses. But you use the bracket when you are including that as a possible value. Okay. Well, I hope that all made sense. And I hope you're able to answer the questions that I left for you. If you're still stuck on some of them, you didn't really get it, doesn't really make sense, you're not sure, feel free to email me. You can email me anytime. My email is ttrigg@ofy.org. So that's trig with 2 G's at ofy.org. Okay, well, I guess that's it. Good luck with the rest of the Algebra 2 class that's coming, and I'll see you guys next time.